Okay, so in this question, we've been presented with effectively CH4. We've been told that the CH4 reacts with oxygen, which is in excess, and produces CO2 and H2O. And we've been asked to figure out, well, what's the volume that's going to be occupied by the CO2 at room temperature and pressure, right? Okay, so how are we going to go about working this out? Well, in order to calculate the volume occupied by the CO2, we're going to need to be able to work out the number of moles of CO2 that's actually produced, and from that point we can then work out, well, what's the actual volume of gas occupied. So how would we work out the number of moles of CO2? Because it's not given to us in the question, right? Okay, so the way I'm going to approach this is, well, the question gives us data which is relating to the mass of CH4, which reacts. Now, if we remind ourselves of the equation that relates moles, mass, and molar mass, we remember that the mass M is equal to the number of moles multiplied by the molar mass MR, right? And so we've been given the mass, and we, although we have not been given the molar mass, we can work this out from the periodic table, right? And if we divide both sides by MR in this question, in this equation, we can then rearrange and say, well, the number of moles is equal to the mass divided by the molar mass, and that will give us the number of moles of the CH4. And we've been told that the O2 is in excess, right? What does that actually mean for our question? Well, what it tells us is that the CH4 is going to be the limiting reagent, right? It's going to really be the main determinant of how much CO2 is produced. Okay, so let's go through the process of trying to work out the number of moles of CH4. So we're going to need to work out the MR. So we can use the periodic table to do this, right? So if we refer to the periodic table, so we've got carbon, we've got 12 for carbon, and then hydrogen, right? So that's going to be 12 multiplied by 1 for the carbon, right? And for the hydrogen, it's going to be plus 1 multiplied by 4, right? So this would be the MR. So MR for CH4, and then we work this out, and if you do that, you should find out you get 16, right? And the units of this is going to be grams per mole. Okay, now what do we do with this? Well, what does our equation show? Our equation shows that the number of moles is equal to the mass divided by the molar mass. So we know here that the mass of the CH4 is 22.85. So what we're going to do is simply use this equation, and we're going to say that the number of moles of CH4 in this particular case is going to be 22.85, right, divided by the molar mass, which is, as we just worked out, is 16. And so if you have a go at working that out, then you should be able to get what our number of moles is going to be. Okay, so if you had a go at that, you should have found that you get 1.428125. Okay, and that's going to be in moles, right? Okay, so from this point, how do we now try and work out the number of moles of the carbon dioxide, right? Which is what we need as per the question, right? By carbon dioxide. Well, if we do a molar comparison here, so what we're simply going to do is to compare the ratio. So the number of moles of CH4, we're going to compare this to the number of moles of CO2. Right, and so we're going to use the balance equation to figure out what the actual ratio is on a molar level. So for every 1 mole of CH4, how many moles of CO2 do we have in the balanced equation? Well, as you can see, for every 1 mole of CH4, we get 1 mole of CO2. So that's going to be simply a 1-to-1 ratio. And a 1-to-1 ratio tells us what? Well, it tells us that the number of moles of CH4 is actually equal to the number of moles of CO2. Okay? And because it's equal, that means that the number of moles of CO2 is simply equal to the number of moles we worked out of CH4 here, which is 1.428125, right? Now, in order to work out the volume of the CO2 produced, we need to refer back to the actual conditions which have been specified in the question. We've been told that we're trying to work out the volume occupied specifically at room temperature and pressure. And we've even been told in the question that at room temperature and pressure, 1 mole of any gas will occupy a volume of 24 decimeters cubed. So for every 1 mole of gas is 24 decimeters cubed. What does that mean? It means that if we have a given number of moles of a particular gas, if we multiply that value by 24, we can work out the volume of gas that's going to be occupied specifically at RTP, right? So therefore, this is the value. So therefore, the volume is going to be equal to the number of moles of CO2 multiplied by 24, right? Which is simply 1.428125 multiplied by 24. Okay, so that, if you work that out, that's going to actually give you the volume. Okay, so if you do have a go at that, what you should find is you get 34.275, right? And that's going to be in decimeters cubed. Okay, now is this our answer? Well, we're going to need to refer back to the question. What does it specify we need to do in order to know really if we've achieved our answer yet? Well, this is what the question states. If you refer to the very end, it says, please give your answer to a maximum of 2 decimal places. And if we refer to the answer we've actually got here, as you can see, this is to 3 decimal places. So actually, we don't have our answer yet. We need to do some rounding here. And so if we round this to 2 decimal places, of course, 5, we're going to need to round it up. So we're going to therefore have equal to 34.2. And then when we round that up, we get 0.28, right? And that's in decimeters cubed. And we can say that that's now to 2 decimal places, okay? And so now this is in effect our answer, all right?